This is part 5 of section 2.6. We want to find all zeros of this polynomial function. Okay, and so we aren't given any of them, so we have to start from the very beginning. First of all, let's figure out how many positive and negative answers we can expect. So for positive, we want to count the number of sign changes here. Positive to negative, that's 1. Negative to positive, that's 2. And that's still positive, so I have 2 or 0. And now the number of negative solutions, change the signs on your negative exponents. So negative, 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 positive. So that's one sign change. Okay, so I have one negative answer and then either two positive answers or two complex numbers. Okay, one thing to remember is that this may be an irrational solution. We could still have square roots in here. And when we do our P over Q thing, it only gives us our rational possibilities. So if you go through all your negative possibilities and you don't get that, you might get it from the quadratic at the end. Okay, let's find our P over Q values. Our P values come from 13, which is a prime number, so that's just 1 and 13. And since our Q value is 1, these are also our P over Q values. So we only have 4 numbers we can possibly try. And since I know I have a negative solution, I'm going to try those first when I know that there's a distinct possibility that I have no positive solutions. So let's just check negative 1. Okay. And when I do that, I bring down the 1 and get a negative 1, negative 6, positive 6, 13, negative 13, and I have a 0. Okay, so I know that one of my solutions is negative 1. Okay, I know I only had one negative solution, so there's no reason to check negative 13. But in addition to that, if you look here, I was testing a negative number and my signs alternate. So even if I knew I had another negative solution, it's not going to be there because I have alternate signs because negative 13 is smaller, it's further away. And here, since I found one solution, I'm going to have a quadratic here, and it is x squared minus 6x plus 13 equals 0, and that's what I need to solve. This does not factor, so go to the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Simplify under the radical and you get negative 16 over 2. The square root of negative 16 is 4i. Okay, and now you can factor a 2 out and reduce it, and you get 3 plus or minus 2i. So here are your other two solutions. So we have that 0 possibility here. We didn't get two rational solutions, irrational positive solutions. So your other two answers are 3 plus 2i and 3 minus 2i. We want to do the same thing here. We have x to the 4th plus 3x plus 7x squared plus 9x minus 18. And we want to find all of our solutions. So first off, let's figure out how many positive and negatives we can have. So for positives, I look for sign changes here. Here I have a positive to a negative, that's only 1. So I have one positive solution. And then for the negative possibilities, change the signs on your odd exponents. So positive, negative, positive, negative, negative. 1, 2, 3 sign changes. So I either have 3 or 1. Okay? So now we need to find our P over Q possibilities. Our p-values come from 18. So that's 1, 2, 3, 6, 9, and 18. And since my q is a 1, these are also my p over q possibilities. So I know I have for sure at least one negative solution. I have one positive solution for sure. Let's do the negative first. I don't know why. So let's test -1. Okay. If I check -1, I bring down the 1, -1, 0, 0, 7, -7, +2, -2, -20. So -1 is not a solution. Okay, so let's check -2. And also, I don't have alternating signs here, so it's not a lower bound. So check -2. Okay. And you bring down the 1, -2, -1, +2, 9, -18, -9, +18, and a 0. Okay, so -2 is one of my solutions. I expect 4. Okay, and if you look here, it alternates signs. So there is no reason for me to test -3, -6, -9, or -18. It is a possibility that -2 works more than once. So I can't say that it's not a solution twice, but I definitely know that those others are not solutions. None of these negatives are. What I'm going to do now I can keep testing these numbers if I want to, but to make my life easier, I really should write down what this is, and then I may be able to adjust my p over q values based on my new equation here. So this is going to be 1x cubed minus x squared plus 9x minus 9 equals 0. Okay? And that's what I need to solve. And like I said, I always look at what I have and I see if I see how it factors. And it looks to me like this may factor by grouping. So it's worth a shot, at least. So if I group these two and then these two together, I can factor an x squared out of the first one, and that leaves x minus 1, plus I can factor a 9 out of here, leaving x minus 1. So this factors as x minus 1 times x squared plus 9 equals 0. From right here, I can see that +1 is a solution, and it was a possibility. Okay, so I found my one positive solution, I found at least one negative solution, and now I need to get my answers from this. So you set x squared plus 9 equal to 0. This does not factor. You can use the quadratic formula, but I would solve this by the square root method. Move the 9 to the right, and then take the square root of both sides, and you get plus or minus the square root of -9, which is 3i. So your other two solutions are 3i and -3i.